Hello, welcome back everyone. So this will be the third example on integration by parts, and the reason I keep re-emphasizing this topic is because it's something that throws off a lot of students, and I really hope that this LIAT method has been really helpful and you guys continue using it through your calculus journey. But today we will be going over this example, the integral of x squared multiplied by e to the 3x. So let's begin like we've been starting. Okay, so now we have to choose which ones are f and then which ones are g prime. Okay, so we have x squared, which is algebraic, and we have e to 3x, which is exponential. Therefore, our algebraic would be f, and then the other one must be g prime. And then we plug it into our formula that we know and love, which is fg minus the integral of, let me do that again, sorry about that, minus the integral of f prime g. Then let's go ahead and do that little guide that I talk about so much. Okay, so we're gonna have our f, and our f prime, our g prime, and then our g. So our f will be x squared. F prime will be 2x. And do you guys see how I'm just doing that? We have our original f function, and then you take the derivative of that, which is just 2x. And then we have g prime, which is e to 3x. And then in order to go from g prime to g, we have to take the integral. So that's going to be 1/3 e to the 3x. And that just comes from our power integration rules that we've gone over in the past. And then we just plug and chug, like I said in the previous video. So we have f, which is x squared, and then we have g, which is e to 3x over 3 minus the integral of f prime, which is 2x, and then multiplied by g, which is just 1/3 e to the 3x dx. Okay, so this is where crazy things begin to happen. So we know that this part is okay. We're okay with that. We're comfortable with that. We've done it already. Now, with this part, we see it, and right off the bat, we can't do u substitution because if we do the derivative of something, it's not going to cancel out with anything. So you look at it again and you ask yourself, do I need to do integration by parts again? And the answer is yes. And this can be quite tedious, but you'll see this a lot. And it's just something that you want to be prepared for so you won't get stumped on a test. So essentially we have to redo what we've been doing. So now you have to determine which one's your f and then which one's your g, like we have been doing in the past. So here I'm going to erase this right here and then use our next two functions. So like we had in the previous one, our f is going to be 2x because it's algebraic, how we had it in the beginning. And the other one, g prime, is going to be our exponential. So it essentially stays the same. So now our f will be right here, and then this will be a g prime. So our f is going to be 2x. And then f prime will just be 2. And then g prime is 1/3 e to the 3x. And now will be 1/9 e to the 3x. And that just comes from our basic integration power exponential laws that we've been taught in the past. And now, like I said, always bring everything down. So, x squared e to the 3x over 3 minus the integral, or minus fg, which will be 2x, and then g will be 1/9 e to the 3x minus the integral of f prime, which is 2, and then g, which is just 1/9 e to the 3x. Here, let me write that again real quick. 1/9 e to the 3x. And I know this may seem a little confusing, but essentially what we're doing is kind of expanding the integral out and reapplying the same formula. There should be a dx right there. Sorry about that. And now, let's bring everything down. E to the 3x over 3 minus... And do you see how I keep everything in parentheses over here? I distribute my negatives all the way at the very end because it makes it a lot easier for me. So I won't have to worry about that mess in the meantime. 1 over 9 e to 3x minus the integral of 2 over 9 e to 3x dx. And now, just bring everything down one more time. E to 3x over 3 minus 2x 1 over 9 e to 3x minus the integral of 2 over 9 e to 3x, which is just be 2 over 9 times 3 e to the 3x, all this plus c. And I just did that because, you know, 2 over 9 is a constant, so I'm basically taking the integral if it was just e to the 3x. And so I would just like divide by 3, and that's where I get all these constants from. So if we're going to rewrite this again and polish it up, our final answer would be 1 over 3 x squared e to the 3x minus 2 over 9. And now I'm including our distribution of negative signs. FYI, e to the 3x plus 2 over 27. That 27 comes from the 9 times 3 at the bottom in the denominator. E to the 3x plus c. And you guys can double check if I made a mistake or anything. But if you guys have any questions, comments, and concerns, please just let me know. And I know this process can be quite a bit, you know, tedious, but sometimes you will have things like this where the integration by parts appears twice. So you basically have the integral and you expand it, and then you have to redo that and just apply the same formula, go with the same process, use your guide, and then just take it slowly. And the rest is just algebraic simplification.